All right, guys, today we are going to do, last week we did the discrete probability. Today we're going to talk about a binomial distribution. This is a little more intense, but once you do the problems over and over again, you'll see it's just a pattern of a formula, okay? First of all, we have to talk about the word binomial. The word binomial has the prefix bi, which means two. Okay, in order for something to be a binomial experiment, it needs to meet these four qualifications. Bi, since it means two, means only two things can be the outcome. So if you are like playing basketball, either you make the basket or you don't. If you flip a coin, heads or tails, you ask a girl out on a date, it's either yes or no. Things like picking from a deck of cards or like picking a person out of a class, that's not binomial because you're choosing from more than two outcomes. Okay, so that's the first thing. And we're going to talk about these as successes or failures. So either you got the card or you didn't get the card, you flipped the coin heads or you flipped the whatever, tails. Okay, the trials have to be independent of each other. And what that means is that when you do the experiment, you're not going to say, well, what's the probability of you rolling a 6 if you got tails on a coin? So it has to be two separate things that are conducted. There has to be a set number of trials. So you have to say exactly what is the probability of exactly 6 out of 10 people watching this lesson. And then the probability for the success has to be the same for each trial. So for example, flipping a coin, the probability that it's going to be heads is always 50%. This would be anything that's not going to change based on like the environment. Okay, so like what's the probability that it's sunny outside? That's not really the same every single day because there are a lot of other factors that play into it. Okay, here we go. Here's the formula. That's a K. All right, this looks fun. Let's just talk about it, okay? This is just going to be the combinations in the calculator. The P is going to be success. The Q is going to be failure. Okay. The K is going to be just coming from this formula. This is your basis of the entire thing. The K is going to be how many times you want the success to occur. And N minus K is how many times a failure should occur. So failures go with failures, success goes with success. Okay? So let's do this first problem. It says Joe DiMaggio, Yankee great, had a career batting average of .325. Okay? That's just an average. That's a probability. So if he went, what's this, 325 thousandths, so 325 out of 10/100th thousandths. That's what this is saying. The probability that he went to bat 1,000 times, the probability he would get a hit is 325. Okay? Either way, it could be a decimal or a fraction. It wants to know what's the probability that he would get a hit at least one hit in 5 official at bats. So we want to know if he had 5 times to get up to the plate. We're looking right now at how many possibilities or how many total events there would be for him to get a hit. Okay? And then all you're going to do is this. What is the probability of success? The probability of success is 0.325. How many times do you want him to be successful? You only want him to be successful 1 time out of 5. Now, all your percentages or your probabilities have to total to 100% or 1. So in order to get Q, we have to do math for the first time. You're going to take 1 minus the probability of success. And you get 0.675. Okay. Now, these numbers should make sense because this totals to be 1. So you're doing the probability of it happening and the probability of it not happening. How many times do you want it to happen? 1. How many chances are you giving him? 5. So that means that 4 of the times you want it to be a failure. Okay. Remember, you can use the calculator that I linked for you to do this, which I will do now. Okay, so there's 5 ways that this could happen. And what that means is, like, if he gets five times up at bat, you want the one hit to happen in any order. So, like, he gets a hit and then strikeout, 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 strikeout. Or strikeout, gets a hit, strikeout, strikeout, strikeout. So all it's saying is there's 5 different ways for him to get one hit at bat. Okay, and then all you're doing is putting this in the calculator. So if you want to put this entire thing in the calculator, you can. This is just going to be 3, 2, 5. You can put this entire thing in the graphing calculator if you want to. I just am going to do it this way, so it's a little bit easier. Okay, that's a very big number, so I'm just going to multiply this all out. And you get 0.337. So there's about a 33.7% chance that if he got up to bat 5 times, one of the times he would get a hit. Okay, now that's a little bit higher than his normal batting average. So there's a chance that he might get 2 hits, 3 hits, but you only care about him getting 1 hit. Okay, so let's say you're the other team and you're trying to say, all right, well, this guy's been up already 4 times in one game. What's the probability he's going to get a hit in the 9th inning? It's going to be a 33.7% chance because he's already missed those 4 chances. Let me just keep going. I know this is a lot. Please just keep watching it. You'll realize that I'm just doing the same thing every time. I know I'm talking a lot, but I'm just so excited. Okay? A manager notes that there is a 0.125% chance or probability that any employee will arrive late to work. So these are already predetermined probabilities. What is the probability that exactly one person in a 6-person department will arrive late? Okay, well, you have 6 people to choose from. You only care about one of them arriving late. The higher that you go, it's going to be a very low probability. Like, if the probability that one person arrives late is like 12%, there's not a high probability that 6 people out of the 6 will all arrive late. So it's already low to begin with. Anyway, so 6, choose 1. There are 6 people, you care about 1. What is the probability that they will arrive late? So this is what you want to happen. So this is going to be considered our success. 0.125. Okay. How many people do you want to arrive late? 1. This is where you do math. Your probability of failure is 1 minus 0.125. Or 0.875. How many people are left to fail the test? 5. Put this in the calculator. Let me see if I can. Let's see. Okay, good. It's not the front-facing camera. Okay, so let me just do this real quick. What's the problem? So I'm going to do it in the graphing calculator. It's going to be 6 NCR1 times 0.125. Come on. To the first power times 0.875 to the fifth power. Doesn't make a difference, but so 0.3846. So about 0.385 or 38.5%. Okay, I'll go ahead and do the last one. A manufacturer has allowed the following quality control check at the end of production line. At least 8 of 10 meet all specifications. The whole shipment is approved. In reality, if 85% of a shipment meets all specifications, what is the probability the shipment will make it through the control check? So what it's saying is that, what is it saying? If 85% of the shipment is approved, it's going to go through. They're saying that you're doing it 8 out of 10 times. So what's the probability that it will actually make it through? It should be a pretty high probability because you're choosing a lot more. So 10, choose 8 times. The probability that it's successful is 85%. How many times do you want it to be successful? 8 times. The probability it fails is 0.15. That's 1 minus 0.85. How many times do you want it to fail? You want it to fail 2 times because 8 and 2 makes up 10. Go ahead and put this in the calculator. I'll do it on the screen again. Let's see. Hello. So here we go. 10, choose 8. Okay, so there's 45 different ways you could do this. Times 0.8. What was the number? 0.85 to the 8th power. Times 0.15 to the 2nd power, or squared. So 0.275. So 0.2758. 27.6%. Okay, I'm going to post this. Let me know if you guys have questions. I know this is kind of a crazy formula, but it really is just doing the same thing over and over again. So after you're done watching this, there's going to be a quizzes, and that's it. Let me know if you guys have questions.